the Schrodinger equation. What exactly is it and why do we use it? Let's first go back in time and see where this equation came from. Erwin Schrödinger was a very famous Australian physicist, and he was the one who had created the Schrodinger equation in the year of 1926, and he had also made some other groundbreaking discoveries which have created the foundation of quantum and particle physics. So what is the Schrodinger equation used for? It's used for things like atoms, transistors, and other different particles. The equation helps us determine the energy of that specific quantum mechanical system. This is the time-independent Schrödinger equation, which basically means it doesn't have time. But what does this even mean? That h that you see with the little bar on top is what we call h bar, which also is called Planck's constant. The 2 meters is just the mass of the object. The upside-down triangle is a short way of writing a derivative, which is d over dx, but because of that exponent 2, it turns into d squared over dx squared. That squiggly line is what we call the Greek symbol psi, which is used to show the state. We have that with a potential function which is v of x. E is the energy. Now how do we derive the equation? We are going to be deriving it by using the energy equation, where energy is equal to kinetic energy plus the potential energy. Now kinetic energy is the same thing as 1/2 mv squared, where m is the mass and v is the velocity. For potential energy, we'll put it as a function of v. Now 1/2 mv squared is the same thing as p squared over 2 meters. The rest just stays the same. P, which is the momentum, is equal to negative h bar d dx all squared over 2 meters plus v of x. Now we had a state, simplify, and we get our Schrödinger equation.